Good morning. Bonjour à tous. ما نعرفش شنو هي اللغة اللي تحبوا تحكيوا بها، ما نجم نحكي لي تروا لونغ كو سوا بالعربي كو سوا بالانجلي كو سوا بالفرنسي. جوست اوكي انجلش باهي. اوكي باش تكون ان ميلونج دونك اوكي اتس ميكس. باهي merci beaucoup pour l'invitation. Vraiment, je suis honoré de participer dans ce séminaire qui est très intéressant avec une thématique qui est d'actualité. Donc 2024 et 2025. Donc 2024, la bête kol tahki à générative AI, je pense qu'il n'y a aucune personne dans le monde qui a à générative AI. Également, you have seen last week what has been announced by American administration, $500 billion to have a new company called Stargate with big companies, so SoftBank, Japan Investment, OpenAI, Oracle. Saudi Arabia announcing $600 billion in AI. So where is Europe? Nowhere. And there is a seminar, I think in February, also organized by Macron on intelligence, on the AI. So we believe that 2025, so AI will have a new level of deployment, okay? And I think that all of you know generative AI. So generative AI, ChatGPT, OpenAI. So all of you already has been playing with it, maybe playing too much. But today what I will discuss with you is the following. So I think that you know this. So you know, to have AI, we need big servers. We need cloud. We need NPUs, big machines, a lot of investment. This is a computer room, okay? And thanks to this, we can enable AI. Now, what we are proposing as STMICROELECTRONICS is the following. So, a small device, 1 centimeter by 1 centimeter, and it will enable the edge AI. And all my conference and all my speech will be about edge AI. So, also, I would like to be a little bit interactive to explain what means edge AI and what we are offering in terms of edge AI. Okay. What we believe that 2025 we will have a new era of edge AI just starting. So basically, edge AI is the following. So that means we do the computing, we do the decision when there is the data. So exactly what has been said by Basirida. So without going to the cloud, without going to the computing, and we can take the decision locally. The benefit is real time, the energy efficiency, because we are in battery effect powered and there is no connection. So in case there is no 5G, there is no Ethernet, we can take the decision locally. So all of this is the benefit, and then it's real time. So that means, what means real time? That means that it's industrial. So we can enable a lot of new process, a lot of intelligence, and the smart intelligence. Now we are talking about Industry 5.0, which is the interaction with human, and to take decision inside the fab. So let's go. So I think some of you know our portfolio for STM32. I will not go in details on this slide, but basically we introduced this family in 2008. So now about more than 15 years. And what is new is the following. So we are introducing all of this series. So we have the wireless, the ultra low power, the mainstream, the high performance, and also the MPUs. So MPUs, it is a 64-bit microprocessor running on Linux or Android. And what we activate also now is the activation of the Edge AI. So we can run Edge AI on all of our MCUs without having hardware acceleration. So we can do a lot of things, and we will see later on. On top of that, very important, cybersecurity. We need security inside the hardware. So cybersecurity is not just software, it's also hardware. By definition, by construction of the device, we need to have all the hardware feature to secure the microcontrollers and all the system from hardware point of view. So let's imagine we can hack a system, and then we go to the hardware and we can find, let's say, a weakness, and from this weakness we can stop the device or hack it. So it's key, and we are investing a lot inside ST to have by hardware, by construction, the security. So security is important when we have IoT device, when we have any device connected. The first question is security. So now, what means the AGI and what we are introducing recently? We introduced a new device which is STM32N6, N meaning NPU. So NPU is a neural network processor unit, which is embedded inside the MCU. And here what we can take benefit is, we can take benefit from the NPU and the MCU and have one single SoC, very small, and able to have this small footprint, low power, low cost, and so fast, in fact, boot and wake up. So just to give you some kind of examples, I hope that the video will run. And by the way, I have the board, so it's not just slides. So the board is here. Also, you can see it and see this new product. So this is something that we can run offline, okay? And I will launch the demo. So the first demo is people count. So you can see, yes. So you can see here. So we are running the YOLO V8. I don't know if you know YOLO. It's running on NVIDIA's NPU, and we are able to run it on a very small chip without connection to the cloud. So this is the first one. It's a key example of what people count. Second one is to estimate if people are stand up or on a chair. You can see it. So it's YOLO V8N. Okay, and last one is hand. So it's a precise system control with hand landmark. So using hand, we can use it as a remote control. So this is just example what we can do, okay, by video, but the opportunities. So in fact, there is many in fact use case. So here what we introduce on this device is the following. In MCU world, so generally when we benchmark a device, we say we have 100 Dresden MIPS or 100 megahertz, for example, or 1 gigahertz. Okay. Now we are entering a new era, so a new way to compute the performance, which is the TOPS. So TOPS is tera operation by second or per second, or jobs. So giga operation by second. It's another, let's say, it's another scale because we can run a lot of operation by second. So I already, I think, discussed the importance of the edge AI. So basically, here we combine the performance of MCU, which is embedded, but also we activate so many features like multimedia. So you have seen in the video, we can have a flux of, in fact, a camera in real time, and then to process all of this inside the chip and take the decision. So now a few data. Maybe some of you already know the high performance MCU of ST, which is the H7. For example, if just I compare H7 by this new product, which is N6, it's 600 times more performance. 600 times. It's a lot. So we are able to run 600 giga operation by second. And in terms of power consumption, we can do 3 tera operation by watt. So if we have 1 watt, okay, so you know it's a battery, 1 watt, we can do 3 tera operation by second. So imagine how many applications we can enable with this. Then we will enter a little bit in the details now, okay, in the MCU world. So basically, if we exclude the NPU side, just we take the microcontrollers. So the system and CPU is running at 800 megahertz, and we have 4.2 megabyte of RAM. So embedded, in fact, memory inside, which is RAM, 4.2 contiguous RAM. We include also a computer vision pipeline, so to have a camera, and then we can encode directly using the #264 encoder, in fact embedded, and we can do JPEG encoding and decoding. Last but not least, security. Okay, so as I said, we embed security by construction, and we are using the ARM Trust Zone Cortex M55. And also we are targeting certification, high level of certification, like PSA level 3 and CCIP 3. So it's a high level for hardware certification for security. Okay, so here is some example of what we can do with AGI. So I think you know all. So number one application is the drones, and you have seen during last month what is the capability of the drones. Imagine we can have such device inside the drone, and what we can do. It's amazing. This is the first application, which is a drone. So it's very used. Okay, without connection. So the drone will fly, no connection with the base, no connection even after 100 kilometers, and it can take the decision based on all the exploration that he will find. Also, in case where there is anomaly, for example, automatically it will land, it will have a secure infect mode. Second application, which is the smart industry, so anomaly detection, for example, to anticipate the maintenance. Smart homes, smart farming, so animal well-being, precision agriculture, the personal healthcare, white goods also. So white goods, we will see a new generation of white goods. So what I mean white goods is the fridge, the oven, so all of this kind of the coffee machine, and a huge interaction with the with human. We have an example inside ST is, for example, it will detect the quality of the bean of the coffee, and based on the bean quality, so it will activate a cycle if you have a good espresso, or let's say light one, etc. by detection on real time on the beans. Then automotive also. Automotive, the area is huge. Okay, so smart automotive. So the driving, but also other security inside the automotive world. Smart building, robots. Okay, so also robots like drone. So for me, drones and robots is more or less the same. Not the same application, but so robots. And by the end, personal electronics. So all the wearables, so smartwatch, wearable, the glasses, and all of this. So all of this application we can enable with such device. Without connection, without 5G, without Wi-Fi, we can do all of this. So as I said, so 6 pillars. So first of all is the real time, so that means low latency, the accuracy. Since we can take the decision and we can run the AI inside the device, that means we can send to the cloud, for example, when we have connection, only the data that we need. Okay, we cannot overload the data on the transmission, in fact, channel. So this is very important. The privacy, of course, the low power, and we can do personalization. Okay, this is more technical, and now I will enter a little bit in detail just to show you how we have done this MCU. So in this MCU, we are selling it in two flavors. So one flavor, which is a standard MCU. We have many applications that don't need the II, just they need the 800 megahertz and to run that, okay? But also we run it with a version which is activated with the II. From our side, just there is a bit, so it's a ROM, and we activate or not. And then the price is not the same, so because we are selling a new feature. Okay, yeah. So inside we have a core, which is a Cortex core, so ARM. So in fact, ARM. So ARM is a company that is bought by SoftBank, and SoftBank was among the new founder of Stargate. So it's the company doing, in fact, the new core. So this core is the M55, so 800 megahertz, and we have a cache, so iCache and Dcache, and we can run up to 3,360, in fact, core mark. So this is the core itself. And most important from our side is the RAM. So I think this is the first MCU on the world having 4.2 megabyte of RAM. In our world, it's huge. Okay, so in the PC, it's very small, but in our world, it's huge because the RAM area is, let's say, is costly, and when we increase the RAM, the die size, so the surface of the die and the sock will increase a lot. So it's, in fact, the price. And we are adding also the external interface. So that means we have no limit in terms of, in fact, memory. So that means we can connect any external, in fact, memory with three interfaces. So the FMC, which is a parallel interface, the Octo-SPI, which is 8-bit interface, and then we have EXAS, so EXASPI, which is 16-bit, so SPI. And thanks to this, we can say we have unlimited capability to execute and run, in fact, code from external, in fact, memory. And here we provide the bandwidth. So if we use the EXASPI, we can have 800 megabytes by second. So now, what have also as acceleration? So you can see here, it's more acceleration for the graphics. So when we run an application like let's say, in fact, video, we added also many accelerators for the graphics. We have Neochrome GPU, which is 2.5D. We have also a Chrome Art accelerator, a JPEG encoder, so only encoder. And we have also a decoder, it's activated by software, and a frame buffer optimization. So with this, we can do a lot of nice screen, and we will see in our next slide. So this is an example. We can take this example. We have the camera, okay, then the memory, and then we can transmit the data, so either by wired or wireless. And this is a case of application with the the H.264 encoder, and we can do that. Yeah. So just one word on security. So what we do in security. So here is all the hardware feature of security that we embed inside this MCU. So there is a lot of things. So first of all, there is a cryptographic hardware accelerator by hardware, so not software. We have also hardware and so isolation. The device authentication. So that means here, in fact, when we have a product and launched on the market, once we do the code, we close it. Once we close it, it's impossible to read inside. And we can have different cycles. So then we can reopen it with a special code and all the security. The memory protection, the active tamper protection, and the trust anchor. So all of these are hardware features that we embed inside the MCU. Okay, so also just to give you example, what are the package we have. So this is not a small package. Okay, so here it's high-end MCU. You can see all package are BGA. So starting from 169 pin, 6 by 6. What I said at the beginning, I said 1 centimeter. Here it's 6 by 6 millimeter. And the biggest package is 14 by 14. So VFBGA 264. So here it's BGA. Of course, we need the equipment to have such kind of, in fact, PCB. And this is all the flavor. So with crypto, without crypto, with IE, and without, in fact, IEI. So now what is also inside, what I can show you is, here is, okay, so here is the core, okay. We have the ST, so neural RT accelerator, which is here. So this is our innovation, which is 600 so giga operation by second. And then we have all the connectivity inside, the memories, the connectivity, the security. For connectivity, for example, you can see to activate all of this, in fact, market, we have the CAN interface, which is very famous in automotive world. We have the USB, we have I2C, so I2C, UART, SPI, gigabit Ethernet with TSN. So I don't know if you know gigabit Ethernet with TSN, which is Ethernet in real time. So we can synchronize, for example, for Ethernet, we can synchronize the frame of Ethernet with a timestamp, and we can synchronize audio and video. So this is a new, also a new protocol, which is industrial Ethernet, used so now in the world. We have audio application, so we can activate also so many applications using audio. We have IDF filter, MDF, the SAE. The analog also performance, so we have 12-bit IDC, 5 megasamples, so many timers. So it's an MCU, okay? It's still an MCU, so not complex, but what we are adding is basically we activate the II, in fact, inside. Yeah. So here's some applications. So you see, we have with the camera interface a connection directly to the MCU, and then we have also, which is a second part of my presentation, is how we can play and what is the ecosystem of software, how we can activate that. Is it easy? Is it complex? And you will see in all the tools that we offer, it's very easy. Even a student is able to get the board and then to have all the softwares. And tomorrow we will have a workshop also to show you this in more details. So here it's a software which is called ESP, which is for the camera interface, which is new. Yeah. So here all the features also we can activate for the graphical interface. So many new features. And this is also to show on all the portfolio of STM32 what kind of graphical feature we can activate. So you can take a very small STM32C0, you can take H5, U5, H7, and with the N6. So the N6. So each time you can have a quality of the graphics that is in line with the hardware feature that we have inside the device. So this is an example. We can run up to 1280 by 720 GUI using only internal fact RAM, and I have the board so you can play with it and see the quality. So we can run all of this inside the MCU. So this is, for example, very used for the white goods. Let's imagine you have an oven, you have a washing machine, and you have a very nice screen, and you can play with that in real time. Yeah, so as I said, now we will enter in the ecosystem. So what we offer, let's say, to our customer in terms of hardware. So for this device, we have two hardware. So one which is basic, which is a Nucleo board. You can see it's on the left. So there is only the MCU, and then there is the connector, and then you can build your application. So the recommended price, we say to our distributor, is $56. Okay, it's international one. Then I don't know here in Tunisia. I think it will in Tunisia. I believe it's a little bit complex to get this device. To be honest with you, because this kind of device, what we say is a dual usage. Dual usage. That means that we can use it for civil usage, but also we can use it for military usage. And to get it, we need an agreement. So the end user should sign something. And the procedure is complex. It's American law. It's not ST. It's not a European one. So Uncle Sam say to all the companies in the world, for dual usage device, you need to sign it. A little bit complex to get it. So maybe also one day, I don't know if you have seen in the news, there is the France of America will get such kind of device, but all other ones, they should apply and to have the green light. And the procedure and the paperwork is very, very heavy. So we'll see. So then the complete one, which is the discovery, and this is the discovery, I have it. Okay. So it's a kit when we have a good LCD, so big LCD, so not so very big. There is the device, the connectivity, and also we embed the camera. Okay. So both package, so the discovery plus the camera, it's about $250. So the camera is a standard one. It's okay. It's a standard fact camera from the market. So then there is some options. We can use ST camera. So we have different fact hardware for ST fact camera here. And now let's jump to the software, and you will see tomorrow in good details. But basically, I will give an overview. So we have a complete, let's say, SDK or firmware. So from the board, the STM32 Cube MX, the different package and expansion, the Cube programmer, and also the monitor. So sorry, we have some security stuff. And also we have many open framework like FreeRTOS, Zephyr, our partner ARM and Kyle, and also we can run the Visual Studio, so VS Code. We have also a tool which is called, maybe you already know it, it's called the ST Edge AI Suite. It's online tool, and inside you can play. You have a lot of online resources, so different models, and you can select your model, and then you can support it on the device. It's a cloud tool. And then you go to the STM32 Cube that you will see tomorrow in the workshop, and using also the ST Edge AI and Fact Core. So all of this suite are for free, okay? So all of this you can download and you can work, so either online but also on the PC. So just there is a small issue on the slide. You can see it's under NDA and confidential. It's not under NDA. It's not confidential, but the watermark I cannot remove it. So on my PC, it's now official. So the Cube AI you will see also tomorrow. So here you have your model, and the QBI is able to optimize your model to work on the MCU. So it will go through an optimizer, a quantizer, a memory optimizer, and then you have the model that you can put inside the MCU. And you will see tomorrow, I will not enter in detail on that. The Edge AI Developer Cloud also, which online tool that you can have the models and also so generate automatically the files, and you can also in fact work on STM32 but also on other ST device like the Stellar, which is automotive MCUs. Yeah, so here are some examples as I show you. So that's all for me. This is what I wanted to show you. Okay. So I don't know if I was on the time, but I would like to have some questions. Okay. So this is this is why I wanted to show you this. I think it's unique. We launched this device by end of December 2024. So 24. And also we have shown this during the CES in Las Vegas 2 weeks ago. I think you have the premium to see this device, and also not many customers, they already have this board, so you will have the opportunity also to see it. So maybe I can run it. Est-ce qu'il y a des questions? Est-ce que ça m'a des questions? Oui.
It's okay, just a minute.
Thank you for this presentation, but I wanted to ask can we run any model or it's just lightweight models in the STM Micro?
Yeah, so here, as I said, we have 600 giga operation by second. So it depends on your model.
So the training is done in the cloud, then you deploy it on in the card, or just you train?
We can do the training on the MCU also. We can do that.
Okay, thank you.
Thank you. Question?
Thank you, Sir Mohamed, for your presentation. I'm interested in knowing what types of optimization for the accelerated cryptography algorithms. I'm interested in knowing what are the applied and industrial algorithms. I know some like XT or XDES or XAES, but it's very interesting to know what are the really ones that are applied.
Yeah. So here, in fact, you can see on the slide. So I think your question is basically on the cryptography hardware and robustness. So we have all of this on the website. So you can see what are the algorithms that we support. So basically, we support the symmetric, the asymmetric one. In fact, AOS, RSA, and all of this. And also we complement. I think. I don't have internet connection here, but if I click on this link, okay, here we have a wiki page and you will see so all the hardware acceleration that we provide.
We are 264-bit enabled for this product, especially for the cryptography one. But for the hash, we are 32 by 32 matrix hashing accelerated inside it. So this is for the technical point. And I think. Merci.
So we have another question here.
Hello. So I want to ask about the programming language. So you know we are using Python now for artificial intelligence, but what I know before that ST is using C.
Yes.
But can we deploy any algorithm written in Python? And
So maybe Nizar will help me because yes, we have. You will see tomorrow on the workshop. Okay, we can have so all the models on the AI, and then the beauty of the tool, it will simplify your life, and it will convert all of this to C code.
Okay,
Even
generate.
you don't need to know what is inside.
Okay.
In fact, it is very simple. It's very to convert whatever the file that you have, whatever the model that you have, either in TensorFlow or in Keras or in MATLAB or whatever the way that you are programming, it will convert it on C, and it will be transparent for you, and more than transparent, it will be more optimized to the capability of the hardware that we will use it. And this is the most important point for this kind of tools, that not only it converts the code, but it optimizes it. And we will see tomorrow, one of this question now, Mohamed said, we are anticipating them for tomorrow workshop, and we will see it in details, and we will focus on this part of the tool.
So basically, in fact, if you are a scientist, okay, let's imagine you are a scientist, you are not a developer, you are not a C developer, you are not expert in C and in embedded. So you bring your own model here in the preferred, let's say, so tool you are already using. You see, we have MATLAB, Keras, TensorFlow.
Very common use tools already.
Then the tool that we have inside ST, this is what we have. So we simplify. So your job, you don't need to know embedded, and the tool itself will reduce the complexity of this model and generate a C code optimized in automatic way.
Yes.
Then of course you can do iterations. So for example, when you play it, you see the performance, you can iterate, you can change some parameter and then reiterate that. This is what we offer. So it's not hardware, but also software. Now, if you are a programmer and expert at programming, but you don't know what is AI, etc., also, we offer that also. You can do in the opposite way, which is the other tool. So this is the Edge AI. So the other tool, which is the Edge AI. So here, you are expert in C, okay, but you don't know what is so the models. We create a model zoo, which we have many models, okay, and you can select one and you activate it. So here we have two approaches. The approach, if you are a developer in C, you are expert. You don't know what is AI, and you are not a scientist, okay, and you are a scientist and you don't know. So we have two tools, and each tool it targets the profile of the people. It's quite new. We are investing a lot on software. We start to develop these two tools in 2016. So, and each time we have feedback from our customer. Our customers are so in fact pushing us to enhance this tool. So now it's a good maturity of this tool, and we are ready to support software but also hardware.
So we're going to pick the last question, actually, because we're running out of time. Yes.
Thank you. I want to ask Mr. Nizar, you were talking about the quantization process or another conversion?
if you are a single user, you can rely on this result and you can use it. Or if you are more experienced, you can optimize more. You can get more flexibility inside the software itself, the model itself. It can also correct your model. If you did something which is valuelessness without value, you can it correct it for you, and it optimize it help you to fit it for the maximum of performance with the minimum of footprint. When we said footprint, that means size of the code inside the memory. Okay.
Thank you. Many thanks. Many thanks, Mohamed, for this very inspiring presentation. I mean, it's very important to be aware what's on the market and the new trends. So maybe my last point to you is, what do you advise as researchers? What are the really high topic in cybersecurity and generative AI that you advise us to track, let's say?
Yeah, for me, my message is very simple. Okay, generative AI, I think it's still a buzz. Okay. It is not generating money for industrial. It is used to efficiency, but for industrial world we need real time. Okay, it's not just generative AI that will help, but we need to use real time hardware to do that, and to generate money and to generate, let's say, added value in the value chain. Generative AI is a big revolution, okay, but it's for human so far. It's not yet for devices. And to generate money, we need to invest a lot on this new technology, which is on embedded AI or edge, in fact, AI. So this is, in fact, my message. And there is a lot of opportunities, and to have really a return on investment. Because as of today, you have seen there is no return on investment. So it's more investment on infrastructure. So big money is injected, but there is no return so far. So all big players saying it's just the beginning of the era. Now what we believe is the return on investment will come with the devices, because devices, we will have billion of devices on the market. And it will come with the device which is hardware. So let's imagine you have a new device, okay, for example a motor, and you embed that, so you generate new motors on the world, so you add value, in fact, on that. And it's coming with, in fact, with that. The other point also, which is 5G. So in Tunisia, for example, 5G is just starting. Okay, what is the difference between 4G and 5G? What is the difference? So if you are human, if you use it for your smartphone, just it will consume more data. So the operator will take more money from you. But you don't need the resolution, because on your smartphone, you have a small screen. You don't need a huge resolution. But the money will come from industrial. 5G will introduce real time, and we need to have that on devices. It's my view of things.
Yeah, it's. I mean, it's very inspiring, and I think.